The second section about quadratics is 9.2. It's characteristics of quadratic functions. So characteristics of quadratic functions. So the first characteristic I want to look at is going to be called zeros of a function. So zeros, maybe you could, if you wanted to, put the s in like a parentheses, a zero or zeros of a function. So again, if you have a function, what's a zero? I don't know if I necessarily write this, but typically we're going to have something like y equals. So y equals 3x or y equals 3x squared. But usually it's y equals something, right? So when you talk about something equaling zero, zero of a function is going to be when y equals 0. And the official definition, I'll maybe put it in blue, or the better way to write it maybe is x values. So it's really saying what x values can you put in an equation that make y equals 0. So if you have a graph, you're looking at where on the graph does the graph cross the x-axis? Where on the graph does the y value be 0? The other way to say that is if you're looking at where does it cross the x-axis, we call those points where it crosses the x-axis the x-intercepts. Does that sound familiar? So it's basically just the x-intercepts. And again, if you wanted to, you could put the s in parentheses, one or more places where it crosses. Or if you're talking about a point, that point, if y is always 0, it's going to be some x value and then 0. So it could be 5, 0, it could be 7, 0, it could be 8, 0. But really it's like that number there is what we're looking for. What's the x value that makes y 0? Good? Okay. So now, when we look at these, if you have a quadratic, and we looked at those being kind of that U shape or that N shape, you have three possible cases. So quadratics, something with a y equals something with an x squared, could have so one possibility is going to be something like this. Maybe I'll make my x and y axis. So if you have one of those parabola shapes, one of those quadratics, maybe something like this, this here is going to have how many x-intercepts? 2. That right there is going to be 1, there is going to be another. So x-intercepts and zeros are the same thing. So this one right here has 2 zeros. So 2 zeros, or if you wanted to, you could say x-intercepts. Or maybe just do x-int or something like that for intercepts. Does that make sense? We could also have a parabola. This time I'm going to draw my parabola first because I found it looks better that way. And you could, if you wanted to make your parabola opening down, maybe I should have done that. But it would work opening up or opening down, but I missed. So maybe put my y-axis there, and I'll fudge my graph a little bit, so something like that. So the second option would be have a parabola, have a quadratic where it just goes down and just touches the x-axis once and then goes right back up. Or maybe it would be a parabola, something like this here in blue, where it comes up, just touches it once, and then heads back down. So either that green or that blue, both of those just have one x-intercept, yes? Yes. So this one here then I'll say has 1, 0. So 1, 0, or 1 x-intercept if you want to. So good? The last option, it could have 2, it could have 1, it could have
3, none.
None, yep. So it was 0. And for that, should I draw the parabola going up again just so you don't think there's something magical about it being downward? So if I have like that. So the last one would be something like this here, a parabola that's entirely up above the x-axis. Or you could have had one down here, one that's entirely below the x-axis, either way. But this one here has 0 zeros. Or 0 if you want to, x-intercepts. So far does that seem okay? And if you were to look at these points, maybe, if you say this point here is maybe like a 2, 0, the 2 is going to be the 0. So that's kind of that when x is 2, the y value ends up being 0. So 2 is the x-intercept, or 2 is going to be the 0 of the function. Fair enough? Okay. Then if we jump on to Roman numeral 2, no questions on that first part? Axis of symmetry. Axis of symmetry. If something's symmetrical, it means both sides look the same, right? So when you have a parabola, if it's drawn right, then it's going to have an axis of symmetry. And that axis of symmetry will always be a vertical line. So it's going to be a vertical line that divides a parabola. And a parabola is just another name kind of for the graph of a quadratic, one of those U or N-shaped things, into two symmetrical halves. Basically kind of cuts it in half. And we talked yesterday about a maximum and a minimum, that if you have a parabola, maybe you could do an example if you want to, but if you have a parabola that looks something like this here, the minimum is going to be that very bottom point, should be right in the center. That's the minimum then. My axis of symmetry should be a vertical line that goes right through that point. So if I could take and fold the screen over, so if I could take this left side here, and kind of like take and fold it right here, and then take this and kind of flip it on top of the other, that this side, this curve, should line up right on top of that right there. Agreed? And that's kind of means it's symmetrical, that it lines up. The other option would be to have one that opens downward. I'll maybe try to do like a real wide one here. Or you could do a real narrow one. But then for that, if it has a certain maximum, if that's the maximum, I should be able to take and do another vertical line right through that point. My drawing leaves a little to be desired, but the left and right side should look identical if I drew it correctly. Close enough for making sense? Okay. Now, if we have this, so that's going to kind of be, if you draw an axis of symmetry, in this thing here. If you have an equation, so for an equation, I try kind of emphasizing that it's always going to be a vertical line. Anytime you have a vertical line, what does the equation look like for every vertical line? Oh, the equation for it. Okay, it'll always be x equals a number. Because for that blue line, if I were to take and put this on, say, a coordinate plane, I wouldn't mess up your notes with this. But if my x value right there is maybe like a 4, do you agree every point on there is over 4 from the y-axis? So we know that x has to be 4 in that case. We don't know anything about y. Y could be 0, y could be positive, could be negative, but x has to be 4. So that one would have the equation x equals 4. Good? Then, so it's always going to be something like that. Now to find that, I'm going to say there's 3 different ways to find it. So the ways to find what is that number that x equals. One, you could say x equals, so maybe 1, x equals the x value of the vertex. So the vertex, we said, was the name of that highest point, the maximum, or the lowest point, the minimum. So if you know that, say, the vertex right here for this one happened to be like a 317, then the equation for the axis of symmetry in blue has to be x equals 3. It's just the x value. Good? So that's one way. Pretty straightforward. Second way, if you have one like this where the parabola crosses the x-axis in 2 spots. I'm looking at this drawing here. Do you agree my vertex is going to be right there?
Yes.
Where is that left-right-wise compared to my 2 x-intercepts? Right in the middle. So my axis of symmetry should be coming like right down through here on this thing. So if you were to take and average this x-intercept and this x-intercept, or average the zeros, you're going to come up with that number right there in the middle. So that's what I want to say for my second way. You could x equals the average of x-intercepts. So x equals the average of x-intercepts. So sometimes they'll give them to you, or you can look at a graph, and maybe the x-intercepts are nice numbers, but where the axis of symmetry is going to be some decimal, use those 2 x-intercepts to get it. Then the very last way, I guess that was number 2. I didn't put a 2 there. The very last way, number 3. Given y equals ax squared plus bx plus c. So once you know a, b, and c, so y equals 5x squared minus 2x plus 7 or something like that. Those numbers before x squared, that's going to be my a value, the number in front of x squared, and so on. But the x-intercept, the axis of symmetry will be y equals negative b over 2a. You could go through also, graph it on a graphing calculator and trace it to find the answer or something like that if you wanted to. But these other ways are going to be easier. Usually 1 or 2. Good? Okay. Then very last section, Roman numeral 3, is finding the vertex. So finding the vertex. Vertex, again, is going to be that point that's at either the bottom of a parabola or the top of a parabola. So when we talk about a vertex, we're talking about this spot right there, the lowest spot on the graph. This spot right there is the vertex.
Be the highest of those.
Yep. If I had one opening down across one like that, then it'd be the highest point. Yep. So we're looking at finding that vertex. Well, for those, we just went over 3 ways to find the x value, or find the axis of symmetry, right? The axis of symmetry is the vertex, or goes through the vertex. So then you could, for your first step, just say, all right, find the x value. So find the x value. And if you want to, you could just say C above. That's the shorter. I'm going to quick write it down here. But you could say C above or do an arrow up to like 2 and 3, at least up above. But A is like the average, the x-intercepts, or the B, which is number 3 up above, x equals negative B over 2A. I kind of like that. It's all in one spot in the notes. Okay, so you find the x value kind of like you did up above for the axis of symmetry. Then step 2, put x in the equation. So put x in the equation. So if they gave you like a y equals 5x squared plus 7, you know x, put it in for x, find y. And then once you found your y value, we're finding the vertex, which is a point, so then you just write as x comma y. So the x value is 5, the y value is 3, so just write the point 5 comma 3. Good? Okay. Quick do that one time and we're done. So example, let's say find the vertex of y equals 3x squared minus 12x plus 4. Y equals 3x squared minus 12x plus 4. Easiest way to find the vertex is probably going to be that equation thing, right?
Yeah.
So, because in looking at it, we can't just look at the graph and pick out from the graph, hey, there it is. We don't know what the vertex is, so we can't just identify it. We can't take the average of the x-intercepts because we don't know what they are yet. So if instead then you just say, okay, x equals negative b over 2a. And if you're looking at that and feeling like it's as clear as mud, until you get used to it, you could take and write out kind of that generic form below it or above it. But this thing in green matches up with this general equation in blue. So what does my b value have to be? Not the top of my fraction. What's my b value? Because I need to do a negative of whatever b is. So b is not 12, it's negative 12. Because you're saying that like this right here, a positive b is a negative 12. So be a little careful to sign. I gave you that on purpose. So it's the opposite, that thing right there, of negative 12, which just becomes positive 12, right? All over 2a, and a is going to be 3. So we get a 12 over 6, so my x value is 2. Woo! This is where I'm losing people. All right, so we know x is 2. And now for the last thing, so we had this equation here, y equals 3x squared minus 12x plus 4. We know that the x value is 2, so I just take a 2 and plug it into my equation. So I have a 3 times 2 squared. That's a 3 times 4, which is 12, minus 12 times 2, which is a 24, plus 4. And you could really just take your calculator and punch all in at once. 3 times 2 squared minus 12 times 2 plus 4 equals. But otherwise, if you do it this way, you should get a negative 8. So that's my y value is a negative 8. So then final answer, you say, all right, it's the point x is 2, y is negative 8. So this right here is going to be the vertex of my parabola. Questions we should go over? I'm not getting a lot of confused looks, so I think we're good. There's one question in the book, or maybe more than one, that says something like this. What's the tallest? You're going to see some story problems that give you something like this and say, what's the tallest sailboat that can fit under the bridge? And really all that they're trying to do is they're trying to say, find the vertex. And they'll have it be where the x-axis is going to be at the height of the water. And so once you find that vertex, is it the x value or the y value gives you the height?
Y.
So it's really just find the y value of the vertex, that's the height of the sailboat. Fair?